Are they? Are they? Okay. Good afternoon, class. How are you doing? I hope you are doing well. Good. Today, we are going to look at lines of symmetry of plane shapes. We are going to look at lines of symmetry of plane shapes. Please, don't confuse this symmetry with cemetery where we bury corpses. This one is SYMME, and then the other one is C. So we say line of symmetry. Line of symmetry. Good. Now the other day, we talked about plane figures. Plane figures. And we saw that the plane figures are also called the two-dimensional shapes. So we have plane shapes or two-dimensional shapes. There are examples. We mentioned the others, or we saw from the previous lesson that all polygons are plane shapes. All polygons are plane shapes. And a circle is also a plane shape. Now let's come to the polygons. A polygon, as we saw, is a plane shape that is made up of 3 or more straight lines. Please note that this straight line we are talking about should be closed. So we say that it is enclosed. So for it to be a polygon, one, it should be enclosed and it should be bounded by straight lines. So if I draw something like this, we cannot call this one a polygon. Why? Because it is not closed. Remember, I said that it should be closed and should be bounded by straight lines, not curves. So we cannot call this one a polygon. Why? Because it is not closed. Now, if we have something like this, then it qualifies to be a polygon because it is closed. And this one here, it is closed by 4 straight lines. Please take note that the number of straight lines of every polygon correspond to the number of interior angles. So if a polygon has 3 sides, it means that it has 3 interior angles. A polygon with 4 sides have 4 interior angles, and so on. Now, polygon with 3 sides have their general name, which we call triangle. Triangle. The tri comes from the word 3, so we have triangle. That is a polygon with 3 sides. So under triangle, we have examples of them. We have many types of triangles. One of the triangles have all the interior angles and the sides equal. It has all the interior angles and the sides equal. Now, that is what we call equilateral triangle. Equilateral triangle. All the sides and all are equal. All the 3 sides are equal. And all the interior angles too are equal. That is equilateral triangle. Good. Then the other triangle is isosceles triangle. We have equilateral triangle. We also have the isosceles triangle. With the isosceles triangle, only 2 straight sides are equal. Only 2 straight sides are equal. It also follows that only 2 interior angles are equal. We also have Scalene Triangle. With Scalene Triangle, none of the sides are equal. None of the sides are equal. I mean, it has different sides altogether. In the same thing with the interior angle. So there's no way we can have Scalene Triangle where we have two sides or whatever. It has different angles altogether, and then their straight lines too are not the same. We also have one important triangle which we will be using very much, and we call that one right-angled triangle. Right-angled triangle. It is so called because one of its interior angles is 90 degrees. So when you see this sign, it denotes 90 degrees. So when you have any triangle and one of its interior angle is 90 degrees, then that triangle is known as right-angled triangle. Very good. When we go to quadrilateral, we also have the same thing. The four-sided polygon have a general name called quadrilaterals. Quad means four. Quadrilateral. So we also have quadrilaterals. Quadrilaterals. These are four-sided polygon. Four-sided. All the sides. I mean, it has four sides. Now, just as we have in triangle, we also have different types of quadrilaterals. One of them is called a square. A square has four equal sides and four equal interior angles. We will see some shortly. A figure like this is a square. All the sides are equal. All the sides are equal. So this is a square. We also have other quadrilaterals. We have what we call rectangle. When you look at this figure, you could see that this side up here and down here, the opposite sides are equal. This side here is equal to this side. Good. So that is some of the characteristics of a rectangle. The opposite sides are equal. It also have four interior angles. Good. We have other forms of quadrilaterals. We have kite, we have parallelogram, we have rhombus, and others. They are all there. I hope we will study them in due course. Now, we also have a circle as a plane figure. So today we are going to look at line of symmetries of these shapes. So in the first place, what is line of symmetry? A line of symmetry is an imaginary line which is drawn to pass through the center of the plane shape. It's an imaginary line which mathematically we call axis. Imaginary line which is drawn to pass through the center of the plane shape or the object. So at the end of the day, what we have on one side should be the same on the other side. When we achieve that, then we say that that line that we draw or we drew is a line of symmetry of the given figure. And therefore, that shape or that figure is known as symmetric figure. It's symmetric. In fact, some figures have more than one line of symmetry. Others don't even have. So if a figure have one or more lines of symmetry, we say that that figure is symmetric. Symmetric figure. Good. So today we are going to look at how to identify line of symmetries of plane shapes. Let's start with triangles. That is three-sided shapes. As I said, one of the triangle is what we call equilateral triangle. Equilateral triangle. So what I'm holding is an example of equilateral triangle. Equilateral triangle. So this is equilateral triangle. All the sizes are equal. Not only the sizes, all the interior angles are also equal. So we have equilateral triangle. Equilateral this shape. And see whether after folding what we have on one side will be the same thing as the other side. In fact, they should be identical. Good. So I'm going to fold this one in the first place. I'm folding it this way.
What's the number? Why you actually the end of my country and say back also I'm an Ebusaka and I'm saying Audi.
Now I'm going to open it up.
Watching in the year and a number, my friend.
Look at this line. What can you observe on both sides? But it is clear that what we have here is identical to what we have here in all aspects. It's identical. Yeah. What I have here is the same thing as what I have over here. So if that one happens, then we say this line here is a line of symmetry. Now with the same shape, let me name the vertices so that you get the concept very well.
Yeah.
A, B, and C. For naming, you just can name them. Good. So when I fold from here, vertex A, you could see that I have this line. So this is one of the lines of symmetry. Now let me turn it this way. If I fold it from this side and I open it, you could see that what we have here is identical to what we have here. So this is another line of symmetry. If I fold it from this angle too, we achieve the same thing.
8 million.
So in short, you could see that equilateral triangle can have or have 3 lines of symmetry.
Oh, when you look at the new
3 lines of symmetry. 3 lines of symmetry. Oh, very good. Let's move on to other types.
Yeah. Oh, say cry new you.
We also have
this
triangle.
Life.
Now let's look at this triangle.
Now the link now my students,
I'm trying to
they can follow you live.
You could see clearly that with this triangle,
whenever they go,
we have this side and this side.
Yeah.
You could see that this side here and this side here,
and the
length is different from the base here. So when you have triangle with 2 sides equal, then that triangle is an isosceles triangle. Isosceles triangle. You call it isosceles triangle. 2 of its sides are equal, and 2 interior angles too are equal. Now, let's see. How do we know the lines of symmetry of this one? How do you determine it? Good. We are going to fold this one just as we did to we have A here, we have B here, and then we have C. Now we are going to fold it along the vertex C. So that is the vertex. When we fold it this way and open it up, you could see that what we have here is exactly the same thing over here. They are identical in all aspects. So because they are identical, this line is termed a line of symmetry. Line of symmetry. So this is one of the lines of symmetry. Now let's try to fold it in B. Okay, give me a minute. Let me take something. Good. Sorry for the interruption. Now we are going to fold it from B, vertex B. Looking at what I have here, there is no way I can fold this one along vertex B to have identical size as I had when I folded it along the vertex A. When I do it on C2, the same thing. So, in summary, you could see that this figure I'm holding, which is isosceles triangle, is having just one line of symmetry. In fact, it's symmetry figure. The number of lines of symmetry is just one. It's one. Okay. Now let's move on. We also have another type of triangle. We also have another type of triangle. Now with this triangle, we call it Scalene Triangle. You could see that the length here is not equal to this one is not equal. So none of the sides are equal. We call it Scalene Triangle. Now, from the definitions that we did, you could see that the Scalene Triangle can have no line of symmetry. There is no way we can get a line of symmetry here. If you try to fold it this way, at the end of the day, when you open it, look at the halves. This half is not the same thing as this half. When I fold it, there is no way you can fold this Scalene triangle to get a line of symmetry. So this shape is not symmetric. For that matter, it has no line of symmetry. Now let's move on to quadrilateral. That is four-sided shapes. Four-sided shapes. Quadrilateral. Good. So we are on quadrilaterals. As I've already said, it's a four-sided figure. A four-sided figure. Now we have examples. One of the examples of quadrilateral, we have square. Square. A square is a quadrilateral with four equal sides, and then the interior angles too are all equal. So all the sides are equal. That is a quadrilateral. Now let's follow the same activity to determine the number of lines of symmetry of a quadrilateral, for that matter, a square. So let's look at this one. So first, I'm going to fold it this way. Have you seen it? Yeah. Now I'm going to open it. Look at this folded line. You could see that what we have on this side is identical to this. For that matter, the line here is termed a line of symmetry. So we have identified one line of symmetry of a square. Now I'm turning it this way. This time I'm going to fold it along the other line. When I open it, the same thing, you could see what we have here is the same thing here. So that one too is another line of symmetry. Now we are going to fold it diagonally. Diagonally. So I folded it diagonally. I just open it up. What do you notice? Look at this line. You could see that this line divides it into two equal identical halves. Therefore, this line too is another line. How many have you gotten? 3. Now, let's fold it along the other diagonal. And this is that diagonal. We fold it like this. You open it up, and you could also see that the side here is exactly the same thing as we have here. So, therefore, we can say that a square, which is a quadrilateral with all the sides equal, is made up of 4 lines of symmetry. 4 lines of symmetry. So a square has 4 lines of symmetry. Good. I hope you're enjoying the lesson. Now let's move on to another type of quadrilateral. We have this quadrilateral here. Now, as compared to the square, you could see that with this one, the this side here and then the side down here are equal. So they are opposite. Now look at this side and then this side. These two sides too, are also equal. So what we say is that with a rectangle, the opposite sides are equal. The opposite side of a rectangle are equal. Good. Now let's see. How do you get the lines of symmetry? So first, let's fold it along this way. So I folded it this way. You could see that what I have here is the same thing as what I have here. If I open it up, you see it clear. The area here is equal to the area opposite. And not only the area, it's exactly the same, identical. Therefore, the line here is line of symmetry. Now we can also fold it along this length. Now when I open it up, this side is identical to this side. So this line too is a line of symmetry. Good. Now let's try to fold it along the diagonals. The first diagonal, wow, I've done the folding. Now I'm going to open it up. What do you notice? Look at this side and this side. Are they the same? No. You could see that this is, when you measure it, they are not the same. So it means that the line here is not a line of symmetry. Why? Because it doesn't divide the figure into two equal, identical halves. Therefore, we cannot refer to this line as a line of symmetry. There is no way we can refer to it. Good. We have other figures like kites. We have kites. I remember when we were young, we used to play with kites. And a kite is like this. Good. Now, this is your assignment. Go and find out. How is, in the first place, is kite symmetric? If you say no, then fine. But if yes, you identify the number of lines of symmetry for me. Good. Now, what I have realized, and I want you to investigate, the relationship between a polygon, that is the number of sides, and then the number of lines of symmetry. For example, if a polygon has it has three sides, which is a triangle, how many sides are there? Obviously, it's three. So I want you to investigate. So if it is three sides, how many number of lines of symmetry are there? On these ones, let's restrict it to regular polygons. Let's restrict this one to regular polygon. Regular polygon. So investigate the regular polygon. We have the regular polygon for triangle is equilateral triangle, you remember. The regular polygon for quadrilateral is a square. Then we have regular pentagon, regular hexagon, we have heptagon, octagon, and so on. So I want you to go and do that exercise. Now let's take another plane shape. Now before we move on to the other plane shapes, you know, when you have the quadrilateral, there are so many shapes, so many types of quadrilaterals. In fact, we have rhombus, trapezium, they are all there. So please, it is your assignment. Go and look for other forms of quadrilaterals and then identify the number of lines of symmetry, if there is any. Good. I hope you remember the shape of a trapezium. Let me just sketch it for you. A trapezium looks like this. Please, I hope you can see it. Then we also have a rhombus. The rhombus is like a rectangle that has been, I mean, it's like a square that can be, or a rectangle that can be tilted. I mean, they call it in other jurisdictions, they call it parallelopipe. It's a very huge word. So just try to, let's put that one aside. Now the rhombus is also like this. The rhombus looks like this. So this is parallelogram. In fact, it's a word that if you don't take care, you bite your tongue. Parallelogram. Parallel. Good. So you could see that it has some special features. The opposite sides are equal and para, meaning that when you see this sign on any shape, it means it is para. This one too is para to this one, and they are at the same time equal. So in fact, go and investigate other types of quadrilaterals and then let me know whether they are symmetric or not. Now let's move on to a circle. In fact, we have circle theorem, which will be a different lesson. Now we have a circle with a center. How is, in the first place, is a circle symmetric? Is a circle symmetric? I think your answer will be yes. Why? Because we can draw what I want you to do for me. In here, as the president has declared a partial lockdown, please, let's abide by it. If you don't have anything to do outside, please learn to stay indoor and try to follow all the protocols. If by any reason you have to go out, please try to observe the social distancing. If you are going out and you think you may not be safe, you can